Okay, students, in today's session, we will be discussing three algorithms. So as you know that in the last lecture, we started with the different techniques. So basically in this particular subject of information security, so in order to secure a system, we majorly use the concept of encryption and decryption, right? So in the last session, we have already discussed how this encryption and the decryption process goes on. So what are the main components in that? Like we have a plain text here, we have a ciphertext there. There is a key that help us to convert that plain text to ciphertext, and also on the destination side, say with the help of the same key, we can change the ciphertext to the plain text. So why we require all this process of encryption and decryption? Just to secure our data when we need to transmit that data on any from one source to the another source. Okay, so we also started with some of the techniques there. So we have a substitution techniques and the transposition techniques. So as you know that in the case of the substitution technique, we mainly substitute a particular character with another character, and it could be a monoalphabetic or polyalphabetic. So in the case of a monoalphabetic, same alphabet can be replaced by the another alphabet throughout the whole process. But in the case of a polyalphabetic, a single alphabet can be changed by the multiple entries. Okay, so in today's session, we will start some of the important algorithms that we may use while we need to encrypt a particular data while transmitting on the network. So these are the three algorithms that we will discuss. One is the Playfair algorithm, second one is your Hill Cypher, and the third one is your Vernam Cypher algorithm. Okay, so the very first algorithm is the Playfair Cypher algorithm. So it was developed in, so we will discuss one by one. And the very first algorithm that we are going to start with is the Playfair algorithm. Okay, so we will start with the Playfair algorithm. So it was invented in 1854, okay, by Charles Wheatstone. Okay, that was a person who developed this particular algorithm. Okay, Charles Wheatstone. Okay, but it was named after another person, that is Lord Playfair. Lord Playfair, who promoted the use of this cipher. Who promoted the use of this cipher concept. The use of this cipher. Fine. So what we mean by a cipher? Cipher is something like that. That is the algorithm for encrypting and the decrypting. So during the encryption, what we are doing, that we are just converting our plain text to the ciphertext. So ciphertext is anything that any third person cannot read in between. So anything that you have changed in such a form that any unauthorized person or a third person will not be able to understand that particular message over there. So that is your cipher. Okay, so cipher is basically, we can say that is an algorithm for encrypting and decrypting part. And what we mean by ciphertext, that is a process which we apply different types of algorithm. Okay, so ciphertext is what? That is the process by which we apply different type of algorithm just to convert my plain text to the ciphertext. Okay, so these are the different cipher algorithm that we will discuss in this class. So the very first one is the Playfair cipher algorithm. Okay, so what we say that we are having Playfair cipher. This is Playfair cipher algorithm. Now we will start with this particular algorithm part. So there are different steps that we need to follow. So first of all, I will discuss the step. And after that, by taking one example, we will understand this particular concept. Okay. So the very first step is that we should create 5 by 5 matrix, a grid of letters. So we will create 5 by 5 matrix having grid of letters. Grid of letters. Letters means all those alphabets that we will include in that 5 by 5 matrix. So if we are taking 5 by 5 matrix is there, so that means total element would be 25 elements will be there. Okay. The second thing is that the matrix will, step 2 will be that the matrix is made by inserting the values of key and the remaining alphabets. So we need to insert all the key elements. Okay, so as you know that we require this key to encrypt that particular message. So what we will be doing here, we will insert that particular matrix by inserting all the key elements. So all the alphabets that will be present in your key, we will first start inserting all those elements in the matrix. Okay, and after that we will add remaining letters. We will add remaining letters. So we will add all the remaining letters. Fine. So we will start adding all those, inserting all those elements, starting with the key part. So as you know that for converting the plain text to the ciphertext, we require a key. So first of all, whatever the matrix that we will include, we will create 5 by 5 matrix here. Second step is that we will insert all the key elements first, and after that we will add the remaining letters. Okay, so we will add all these elements row wise. So how we are adding? Row wise we will be adding. That is left to right. Left to right we will start adding all those. Okay, but there is also one case that we have to include this I and J. Wherever I will come, we have to include that I and J in the combined way. So this is also one of the conditions. I and J in the combined way. Okay, so we will be adding this letter I and J will be combined together. Fine. So next thing, third step is that we will convert the text into pairs. Convert the text into what type of a text? Plain text. Okay. Which text we are talking about? That is plain text. We are converting the text into pairs. Into pairs of alphabets. Okay. So firstly, just understand that particular steps, and after that, so after that we will take one example and we will solving all this. Okay. See, there is some particular condition in pairing part that we cannot pair. Pair cannot be made with same letters. Okay. Pair cannot be made with same letters. Okay, so we will break that letters in single and add X to the previous letter. So what will happen that we will break that particular letter, like we are having hello here. So here you can see that what type of a pair will be there. H, E, now L, L, both are same, but we won't be writing like this. We will write like this. L, X, L, O. Okay, so first, these two letters are there. Then we have these two, but the rule says that we cannot pair two letters same. So what we will do, we will add that X to this particular L part, first L part, and remaining two letters we can write like this. Fine. Next is that. So if we we are having another word like this, hello, E. So how we do all those pairing here? H, E, L, X, L, O, and the last letter will remain the single one only. Right? So this is the first rule. Second rule says that if that particular letter Okay, so if the letter standing alone, if letter standing alone in the process, then we have to add add z to it. Add z to it. Okay, so previously what we were doing, like we are also having the same letter, and while pairing we are left with a single letter. So first rule says that if we are having the same letter, consecutive same letters are there. So what we will do, we will add that x to the first letter, and we will just pair the next two remaining letters here. And the single letter that will be left here, we will add z to it. Okay, so what we will do, we will add z to it like this. E. Again, like we are having H E L L O E. So we are working like this: H E L X L O, and last is E X. Sorry, E Z. E Z. That is E Z will be. Okay. So this was about that if the letter is standing alone in the process, then we can add that Z to it. Okay. Now what will happen? Now there could be a case like here we are adding this S to the similar letters. Okay. But there could be a situation that X will be also there. Okay. We are having the similar that X letters in the text. So I want to say like this, like we are having H E X X X X O. So let's suppose we are having like this. So what we do here, that like here we have added that X part in. But in my this particular text, X is already there. So what we will do, we will add like this H, E. These are the first two pairs. Now both these pairs are same. So what we will do, we will add like X, Z. अब हमने with this particular x, I am adding this z. Why so? Because already we are having that x. Okay. Now what we are left with x again. So we are having x o, and the last one is e only. This is a single digit. We will add e z. Okay. So we are adding like this e z. So these are some of the basic rules that you need to remember if you are going for this particular Playfair algorithm. So there is another step also, or there is another rule also. So I am just going to repeat all these steps. Just listen to it carefully, because when we will implement this particular algorithm, so I won't be able to write all this thing again. So just keep all these points in your mind. So the first step is that we have to create 5 by 5 matrix. This is a rule in Playfair that we have to include this 5 by 5 matrix. Fine. Second thing is that insert all the key elements. So what we do, obviously with the plain text, we will provide it with the key. So we will start first inserting all the key elements here. And after that, we will add the remaining letters row wise. So let's suppose if we are having like this. So this type of a matrix will be there. This type of a matrix will be there. Let's suppose we are having that key. Okay. So key is, let's suppose we are having that A, B, H, I. B is the key. So I will start adding like this A, B, H, I. Okay. So the 5 by 5 matrix we have created, insert all the key elements. I have inserted my all key elements. This is just an example. After that, we will discuss in detail. So we have inserted all these key elements. So what the second rule say, that insert all the key elements and add remaining letters row wise. Meanwhile, wherever we find that I, it should be included with the J part also. So we have to by default write J here also. Okay. And after that, add the remaining letters over here. So what are the remaining letters here? So let's Suppose A is there, we have included the A part, B is there, C is not anywhere. So we are writing like C. Okay? Then D is not there, E is not there, F is not there, G is not there, H is there. Fine. So on we will include all these elements. So we will discuss in detail when we will start the implementing the example. Okay, this is the how we have to insert all those elements. Third rule says that convert the text into pairs of alphabets. Now, what type of a text we are talking about? We are talking about plain text in the third part. Okay, so for what we will do, we will just divide our plain text into pairs of 2. This is also always remains the same, that we require pairing rule. Now there is a rule for pairing also, that if we are having consecutively same letters, so what we will do, we will add that particular X with the first letter, and we have to just pair the next two elements like this: HELXLO. But there could be also a situation where you are left with the single alphabet only. So like this, HELXLO and E is there. So we have to add that Z to this E part. Because pairing is necessary, so we need to have some particular pair here. So we will write like this: E, Z. Okay. So if X already, if sometime like we are saying that if we are having same pair, same alphabets in a pair, so we have to replace it with the X value. But let's suppose there could be a situation we are having 2X only, like here HEXXOE. So we are writing like this: HEXZ. Okay. Now we don't include that X here because we are already available with this particular value of X. XZ, XO, and EZ. So EZ is the last alphabet, single alphabet that is left. Fine. So these are some of the rules that you must keep in your mind. After that, there is a rules that how we can get the ciphertext. So keeping all these 3 rules in your mind. So last rule is that step 4. So just keep all these rules in your mind. And obviously, I will be discussing the same after the completion of lecture. So kindly listen all the concept and just carefully so that you can answer my questions. Okay. So here you can see that what rules we need to find. So this is the step 4. So step 4 says that if both the alphabets in a pair comes in same row. Okay, same row is like this. Same row it will come. If both the alphabets come in the same row, replace them with alphabets immediate to right. This is the first rule for converting the plain text to the ciphertext. If both the alphabets are coming in the same row, then what will happen? Just replace them with the alphabets that is to their right. Okay. Then we are having, if both the alphabets are in same column. Okay. If both the alphabets are in same column, then what we will do? We will replace them with alphabets immediate down to it. Okay, immediate below them or immediate down elements, down alphabets that will be available. Or you can write like this: below elements. Okay. So if now same row case is there, same column is there, but there could be also a situation where you are not having that same row and same column. So in that case, replace the alphabets, replace them with alphabets in the same row, but Add other pair of column in same row, but add other pairs of columns. Okay, so just remember these three rules that we require in order to convert our plain text to the ciphertext part. Okay, so what the first rule says that if both the alphabets are in the same row, replace with the alphabets to the immediate right. This is the first rule. Second rule says that if both alphabets are in the same column, replace them with the alphabet immediately below them. And third rule says that if none of the alphabet is in the same row or same column, so what we will do, we will replace that particular alphabet in the same row but at the pairs of the corner. Okay, so I will start with this particular example. Hope you have understood all the rules here. Okay, so now I can start with that particular example. So if some doubt is there regarding any type of a rule, so just listen that particular example carefully so that it can help you to understand the concept of this Playfair technique. And this is one of the important techniques. So let's start. Let's suppose we are given with this particular key. So first of all, I will take one example. Okay. And after that, you can just see that what are the different pairs we can take upon and what value, what answer will come there. Okay. So let's suppose my key is like this A, B, H, I. So what step one says that first of all, we need to include that particular matrix of 5 by 5 matrix. So this is your 5 by 5 matrix together. Okay, so this is your 5 by 5 matrix is there. So first rule says that this is the first rule that we need to create 5 by 5 matrix. Second rule says that start inserting all those elements starting with the key elements. So what is the key available to you? That is Abhi. So I will write like this: A, B, H, I. Simultaneously, it says that if you are having that I alphabet there, so you have to include J with also. So we are including like this J there. Fine. A, B, H, I. So I is there. So we have to include that J with also by default. This is the second rule. Now complete the insertion part with the remaining letters in your this particular alphabet. What are the remaining letters? We will start with all those alphabets. So that is A is there, B is there, C is not there, D is not there, E is not there, F, G, H is there, I is there, J is there. So last one is your A. Then L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so see, we have included all those alphabets here like this. Fine. Now, I will just take some plain text by default just to make you understand that what are the rules to convert that particular plain text to the ciphertext. Now, let's suppose in my plain text, if I include, so I will write here so that it should be visible to you. I can write here like this 5 by 5. So you can include here. So let's suppose my plain text is BM. This is your plain text. Okay, this is your plain text. So I just be more clear so that you can understand. So what was the key here? Key, Abhi. So this is my plain text, and here I will define my ciphertext. Okay. So let's suppose my plain text is VM. PM. Okay. So we have to see that at which particular part this B and M is available. Yes. So we are having B here and M is here. So both the alphabets are in the same column. They belong to the same column. B and M is there. Fine. So both the alphabets are in the same column here. That is B and M. So what rule says that if they belong to the same column, so what will happen that they will be replaced by the alphabets immediately below them. So what is the below element of this B? That is E. So we are writing like this E, and before below this M, which alphabet is present? That is R. So this will be the answer. Fine. Say, let's suppose my another plain text is R W. That is R W. So again I will say here is my R, here is my R, and where is W? Again here. That is here. Okay. So below this R, which alphabet is present? That is W. And below this W, no alphabet is present, but it will move towards a starting point. So what element we will be having here? That is B. Fine. Next is that F, G. So next combination of letter is F, G. So what will happen? We are having like this F and G. This is your F, this is your G. So both these alphabets present in the same row. Okay, so both these alphabets are present in the same row. So what will happen? You have to just assign the immediate alphabet to this particular letter. So what is the immediate alphabet of this F? That is G. And what is the immediate alphabet of this G? Is K. This is your K. Fine. F is having G with it. G is having K with it. Fine. So this is how we are converting the cipher text to the plain text to the cipher text. Next is that U, Q. So I have just tried to show all the combinations. So that will help you to understand in case in future if you get any type of example. So you are having U and Q here. So what is the value here? That is U is here, U and Q. Again this U and Q both belongs to the same row here. U and Q both belongs to the same row here. So what is the immediate, now after this U, we are not having any type of alphabet here because our matrix is, but it will refer to this particular element. So we are writing like this Q, and after this Q, we are having R. So we are having R. Okay, that is Q, R is there. Fine. So this is how okay, so this is how we can say that U, Q, Q, R is there. Clear? So this is also one of the combinations. So if it is a last alphabet, then we have to move to the very first alphabet of the same letter, of the same row or a column. So in the column case, this was the last alphabet, so it moved towards the starting one. So in the case of the row alphabet, you can see that this is the last element, so it moved to the first element. Okay. So next is that we are having Q, W. Okay, Q, W is here. So this is, again, we can see that this is your Q element and here is my W. This is the W element. Now this one is tricky because both the alphabets not belongs to either the same row or the column. So we are having Q and W here. So what we will do here, we will be take the corresponding letters for the same diagonally. So we are using R for Q, we are using R, for W we are using B. Okay, so for Q we are using R and for W we are using B. Okay, next is the KL. KL is there. Okay, so where are K? This is your K and this is your L. Again, both these alphabets doesn't belong to the same row or the column. So they are diagonally available. So we can see that K, correspondingly K, we are having this D, and correspondingly L, we are having this P. Okay, so we are having D and the P. Okay, K, D, L, P. For L, we are having this P. Fine. Next is K, S. Okay, K, S is there. So again, you will see that where is K? This is your K. This is your S. K, S. K, S. You can see it. Okay. So what will happen? So you have to create that particular form in the diagonal part. So we are having K. So correspondingly S, which element is present? F. So we are writing like this. Right? For correspondingly S, if we see according to K, which diagonal element is available? U. That is F. U is there. Okay. So this is the way that how we can represent, how we can use this Playfair technique. Okay. So I have, by using all this example, we have just defined what are the different rules that is available to us. Okay, so these are some of the examples that we can include. Okay, so we have tried including all those examples here by defining all the possible combinations of letters so that all the rules you will be able to understand here. Is it fine? So I think we are done with this particular Playfair technique. So now we will be switching towards the next technique here, that is the Hill Cypher. Okay, so that is the Hill Cypher technique. So next technique that we are going to start with is that Hill Cypher technique. Okay, so next technique is that is a Hill Cypher. Okay, student, I just repeat the concept here. So that is a Hill cipher here. So Hill cipher is basically a polyalphabetic that is technique here. And in that polyalphabetic technique, we are having it was developed by a person Lesser Hill, that is not in 1929. Okay, so what Hill cipher says that the first rule is that we need to define the key here. Okay, so the first rule says that we need to define the key. So before encrypting, what method we are using for encryption part, that is C equal to KP mod 26. Okay, so this is the basically encryption notation that we use, C equal to KP mod 26. So what value we are taking, that is K is for key, P is for the plain text one. Fine. So the first rule says that we need to define the key here. So how we can define that particular key? That we need to include the square matrix here. Okay? So whatever the key value should be given to us, it should be in such a form that you should be able to make that square matrix here. So how we can define that square matrix? By taking this 2 by 2 matrix or 3 by 3 matrix. So 2 by 2 matrix, we are having example like this, that there is a view and we can write like this VIEW, that is your 2 by 2 matrix. And let's suppose you are having some key like this where you are having total 9 elements. So you can define like this QUICKNESS. This will be your 3 by 3 matrix. Okay, so that will be your 3 by 3 matrix that will be available here. So this is the example of your 2 by 2 matrix and this is the example of your 3 by 3 matrix. Right? So this is how we can define this particular term of Hill cipher. So in that case of a Hill cipher, we need to define the key first and we have to include this particular formula. And there is another rule in the case of a Hill cipher, that now we will define all those alphabets with a numeric value. Like what alphabets we are having? We start with the A till Z. So total alphabets are 26 elements are there. Okay. So total 26 elements are there. So we will just define A as 0, B as 1, C as 2, D as 3, so on till Z. So what will be the value of Z? That is 25. So just keep all these values of the numeric value of this particular alphabets in your mind so that you will be able to understand, because in future we will be including all those alphabets by its numerical value. Fine. So we will be including all those elements into the numeric value. Okay. So we can write like this. So we will start here. Let's suppose. Okay, two things you must remember. First thing is that is whatever the key that you are using, that should form a square matrix. So square matrix could be 2 by 2, 3 by 3, 5 by 5. You can include anything. Okay, but it should be a square matrix. Secondly, is that we have to use the numeric notation for each alphabet. So you can see here that whatever the numeric alphabets you are having. Okay, we will start here like this. Let's suppose my plain text is, so before starting this algorithm, just remember two things. We have to include the numeric value for each alphabet. So we will start with A. A value is 0 till the Z value, whose value will be 25. Fine. Secondly, we need to include that particular formula where we are having that ciphertext equal to KP mod 26. Fine. So, and the third rule is that we need to include that particular square matrices, either 2 by 2, 3 by 3, 5 by 5 or anything. Okay. So let's suppose my plain text is attack. Okay. And let's suppose I am including my key as 2, 3, 3, 6. So what value we are having? So just for your reference, for the first time, I am writing here like this: B1, C2, D 3, E 4, F 5, G 6, H 7, J 8, so on till Z equal to 25. Okay, so let's suppose I am taking my key in the form of 2 by 2 matrix. So according to this, what value we are having? C. At 3 we are having B, D, and for 6 we are having G. So C, D, D, G. That will be your key. Okay, so what will be your key here? That is C, D, D, G. That will be your key. But I have converted this particular key alphabets into the numeric part here. Okay. So what we are doing here, the third rule that you need to remember here is that when you are taking 2 by 2 matrix, so what will do? Your plain text should be converted to vector length 2. Vector length 2. Okay. Your plain text should be converted to vector length 2 here. Okay, so this is how you can just define all those things. So it should be converted to the vector length 2. So what we mean by this particular term, that is vector length. So we are writing like this. So that is a vector length of 2. So what is my plain text? PT is A, T, T, A, C, K. Okay. So now we are taking this vector length of 2. So we are writing like this A, T. Here in is such a form. Then we have T, A. This is your next pair. Then we have C, K. That is C, K will be. So this is 2 into 1, 2 into 1, 2 into 1. Okay. So 2 rows and 1 column are there. Okay. So 2 rows and 1 column will be there. Now our encryption process will begin. Now what will happen? Our encryption process will begin here. So what encryption formula we are having here? So we can write like this. So what is the first vector here? That is, so the first vector we are having, that is A, T. A, T will be. Now what? This is your first vector A, T. Fine. So A, T. So this is your first vector, that is A, T. Now what value of A we are having? That is 0. Positive. What value we are having? That is 0. And what is the value of T we are having? That is 19. Okay. So that is, okay. Second is 0 and 19. For the value of T is 19. Okay. And what key we are having? What is the key that we will be having here? That is 2, 3, 2, 3 and 3, 6 will be. Okay. So that is 2, 3 and 3, 6 will be there. So I just clear out all these things so that you will be able to understand more clearly. Just remember the previous points that I have already discussed with you. Now we start with this particular point, like what key we are having here. That is 2, 3, 3, 6. This is the key point. How many vectors we are having? That is of length 2. So we are having all those vectors. So the first vector was that is AT. AT. A tag was the word. So we were having A, T, T, A, and C, T. So this is our plain text. We need to convert this particular plain text to the cipher text. Okay. So we need to convert this particular plain text to the ciphertext. Okay, so this was your CT, that is your plain text, and you have converted your plain text into 2 by 1 matrix. Okay, so the very first one is the KT. We are writing like this KT. What is the value of KT? A 0, and what is the value of P? That is 90. If you go this first. Okay, so what key we are having here? This is your key part. This is your first value. Now, what we will do? Let's suppose we write the key here. That is 2, 3, 3, 6. This is your key. Now we will use this encryption formula. That is C equal to K P mod 26. Okay. So what we will do here? We will multiply both this form. Okay. So 2, 3. This is your key. 2, 3, 3, 6. What is the value of P? That is 0 mod. Okay, and we are having mod 26. So matrix multiplication will be there. So what type of a matrix multiply? 2 into 0 plus 3 into 90, 3 into 0 plus 6 into 9. And we have to include mod. Okay, so what will the answer that we will getting? 0 plus 57, 0 plus 114 will be the answer. And finally, we will be getting here, final answer that we will be getting here, 57, 114. And that is mod 26. Okay, so after calculating with it modulus 26, what answer we will be getting here? That is 5 and 10. Okay, that is the 5 and 10. So what is the value of the 5 here? That is F. And what is the value of 10 here is the K part. F and the K. So first value is the F, and the final value that we will be getting here is the what value we will be getting correspondingly to this particular part, that is the K part. Right? Yes, it is I, J, K. So, okay, so what value of K we are having? That is 10. So this is your final result. Okay, so that will be your final result here. See? Right? So what are the different steps that you need to follow here? That first of all, I just again repeat all these points. So the concept will remain from the remaining vectors also. First of all, Hill cipher is a polyalphabetic cipher technique. It is a polygraph method. Polygraph method says that we just encrypt a group of characters. Okay. So the first rule says that if we need to perform the encryption part, so what we will do, we will just add this. We will just use this particular formula, that is C equal to Kp mod 26. Fine. Second thing that you need to perform here is that we need to choose a key here. So while choosing a key, you should remember that. Okay, you should remember one thing, that either you should take 2 by 2 matrix or a 3 by 3 matrix. So in my case, what type of a key I am getting, that is a 2 by 2 matrix. So what we will do, I will just convey, my matrix is 2 by 2. So I will be converting in under the vector length of 2 bar. So whatever the plain text that will be giving to me, I have converted into the 2 bars here, that is A, T, T, A, C, K. Okay. Now, according to this particular rule, what I will do, that I have to include all the numeric values for the corresponding letter here. So like A and T is having the value 0 and 90. So the next step is that I need to multiply both these matrices. This matrix also and this matrix also. Okay. So both these matrices I need to multiply. So I will perform all those calculations. And finally, by doing this mod 26, I will be getting this particular value. And after calculation with this mod 26 part, what values I will be getting here, that is 5 by 10. So that is obviously according to that corresponding value we have to see over here, that is 5 and 10, that is F and K. Similarly, what is the next vector? Second vector is T, A. Okay, so what is the value of this T and A? So the value of T was 90 and what was the value of A? That is 0. So again, what we will do here? 19 and 0. Again, we are having the T, 2, 3, 3, 6. So after doing all those calculations, what value again we are having here? That is 12, 5. So according to this 12 and 5, what corresponding letters we are having? That is M and F. That is M and F here. Okay. So that is M and F here. So this is your second vector. Similarly, for the third vector is your CK. So CK, after doing all those calculations, what value you are having here? That is I. I just write here, that is I and O. Okay, that is I and O that you will be getting here for your last element. Okay, so that is your I and O values that you will be having for this particular. So this is how you are doing all those conversions here. Okay, so the next thing that you need to remember that how we can calculate this particular mod part. Okay, so this is how you are calculating the mod part. So I just tell you one technique by which you can easily get the modulus of this particular number. Like let's suppose we are having 275 mod 26. So how we can perform this particular part? We just write like this: 275 divided by 26. Let's suppose the answer is 10.5769. This will be your value. Okay, so first of all, we will divide that particular number with 26. This is the calculation I am showing you that how we can find this modulus part. Okay, so 10.5769 is your number. So what we will do from this particular number, that is 10.569, you have to minus this particular part, that is 10. Whatever the number it will come before this point, you need to minus that particular number. So you are getting like this 0.5769. Okay, and after that, in the end, what you will do, multiply this particular number, that is 0.5769, multiply it by 26, and you can get the value as 15. So this is a way that how you can calculate the modulus of a number. If calculator is not available to you, or if you can't perform that calculation in the easy way. So this is the easy method. Only 3 steps are there. So you just remember all this. First, divide that particular number by 26. Whatever the answer that you will come, you can write here. And after this particular number, what you will do, whatever that will come before this point part, just subtract that particular part from this particular number, and equal to, that is this number that you will be getting here, that is 0.569, and after that you can multiply this number by 26. Okay, so that is a 26 because you are finding that particular modulus with 26, and this is the answer that you will be getting. Okay, so this was all about the Hill Cypher algorithm. So this is also one of the important algorithm in your this particular topic of induction and deduction. Now the last method that we are left with, that is quite easy one as compared to the Hill Cypher and that Playfair method that we have already done. So I'll just take 5-7 minutes just to dictate that particular method. Fine. So that is the Vernam Cypher technique. So the method that we are discussing in this particular class is the Vernam Cypher technique. So Vernam Cypher is basically used for encrypting the alphabetic text. Okay. So it is simply a type of a substitution cipher. So just remember, whatever the types that we are discussing, you must remember that under what particular category it comes, because many times in exams, simply questions may ask that what type of a explain any type of a substitution technique or a polyalphabetic technique. So you must remember that what type of technique that you need to represent there. Secondly, you just remember the same concept that we used in the case of a hill cipher, that we have to give the numeric notation to each and every alphabet. So starting with the value of A to 0 till the end, here we have given the value Z as 21. Okay, so in this particular main thing that you remember in the case of a Vernam cipher, that the length of key should be equal to length of plain text. Now this is the rule, you can say, or this is the, you can say that this is the main prior condition that you may require. Length of key should be equal to length of the plain text. That thing you must keep on, then only you can perform this Vernam cipher. Now let's suppose we are having a plain text that is hello, and there is a key. Let's suppose we are having V, A, X, Y, Z. So first rule, what says that Vernam, that same length of key and plain text should remains the same. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this particular, this we can say that requirement just meet our requirement. This particular given condition meet our requirements. So now we will start with this particular equation. For the encryption process, what it says that, let's suppose what plain text we are having. So what value of plain text we are having here? H, E, L, O. L, L, O. So what is the value of H we are having? 7. What is the value of, like we are having H, E, L, L, O. What is the value of E? 4. What is the value of L? That is 11. And what is the value of O? That is 14. That you can just check from all this particular type of thing. From this chart, I have substituted the values of this particular alphabet set by its numerical. Now the key, what is the key is given to us? That is B, A, X, Y, Z. Okay. So what value of B we are having? 1. Okay. So we are having, what value of B we are having? 1. A we are having 0. What is the value of X will be there? 23. Y will be 24. And last one is, sorry, this is C one. Okay. So last one we are having C. So that is 2. Clear? Now what we will do, so again we have substitute the numeric value of particular alphabet for the keys also. Now the third step is that we need to add plain text and key. So we are adding all those plain text. So now let's add that particular value. 7 plus 1, 8, 4, and this is 4, 34. We are having, again we are having this 35, and 14 plus 2 is 16. Okay. So what now you can see that this is the ciphertext that we are getting here. But what our numeric value says that we cannot include any character after this Z equal to 25. So we are also having this 34 here and 35 here. So wherever if the value of the numerical value is greater than 26. Okay. So what we do, we will subtract by that particular number with 26. If the value is greater than 26, subtract 26 from it. So subtract 26 from it. So 8 will remain the same, that is 8, 4 will remain the same. 34 is greater than 26. So what we will do, we will subtract this 26 from 34. So what answer we will be getting here, that is 8. Again 35 is there, we will subtract 26 from 35. We will getting 19, 16 will remain the 16. So what is the value of the ciphertext here? So corresponding to 8 we are having I, corresponding to 4 we are having E, again I, and again 9 we are having J, and for 16 we are having the value G. So this is my ciphertext. Okay, so this is my ciphertext. Here concept is simple. Only remember in the case of a Vernam that your size of length of key and length of plain text should be same. Okay, so 5 is there, 5 should be there. Convert that particular plain text to the numeric values by checking the values from this particular table. Also allocate the numerical value for this particular key also. So you can give all those values. Third step is that add both the values. So you can get the answer. So if your value is greater than 26, subtract this 26 from it. So in my case, only these two are the condition where my value is greater than 26. So what I will do, I will subtract this 26 from it and I will get the concluding answer. And finally, just replace that number, numerical numbers, with the corresponding alphabets. So this is the concept for the encryption part. Now we will perform its decryption also, because it is quite a simple way that how we can perform the decryption part. So what is the ciphertext that we have received there? So this was your ciphertext I, E, I, J, G. Okay, so this was your ciphertext. Now let's start for the decryption part. Okay, so decryption part. Okay, in the case of encryption, we have included the plain text, but here we will include the ciphertext. So I, E, I, J, G. So what we are doing, we are having value 8, 4. That is I. For I, we were having again 8, 9, and 16. These are the value for the ciphertext. Again, we will use the key here. So what is the key that we will be having? So V, A, X, Y, Z. So with the key we are having 1, 0, 23, 24, and the V, A, X, Y, C will be there. So these are the values. Okay. So here what we will do, I will just ciphertext minus key. I will perform the formula. At encryption part, I was adding both the values. Here I will subtract both the values. So 8 minus 1, that is 7, 4. And here we will be getting the value in the form of a minus 15. Okay. So after that, we are having this. Now, again, there is a condition that the alphabet that whose value is up to 26, that is okay. But here we are getting the value in the form of a minus part, or in the form of a, we can say that negative value is there. So what we will do, that if we are having if numbers having negative value, what we will do, we will add 26 to it. We will add 26 to. Okay, so what we will be doing, we will be adding 26 to it. So 7 will remain the same. Okay, because its value is up to 26, 4 will remain the same. We will add 26 to it. So while adding 26 to minus 15, what answer we will be getting? That is 11. Again, we will be getting this 11. And here, there is 14. If you see corresponding letters here, so you can see for corresponding H, we are having 7, we are having H. For 4, we are having E. And for 11, we are having this L, and for 14, what value we are having? That is a O. So this is the plain text that we have received. Okay. So these are the particular algorithm that we need to discuss in this particular session.